Okay, so her question was, I believe, if you have a limit, and be careful about this, guys. People start memorizing limits, and that's where they go wrong. You don't want to memorize. I mean, it's okay to know some of the rules, but remember, when you think towards infinity, if you have a limit to infinity, what you're really thinking is about, if it's a fraction, you're thinking about a growth rate. Where does it grow faster, top or the bottom, or the same? And if it's not a fraction, you have to think about the graph, which is what I think you're asking. You're saying if I'm taking a limit of, say, sine or cosine, and I'm going to infinity or negative infinity, if there's nothing else going on, and it's just like sine of 5x, sine of 2x, something like that, then because it oscillates between two fixed points, because it oscillates like that, it never is approaching a single y value. So if it's not approaching a single y value, you would have to say the limit doesn't exist. Now, there are graphs that oscillate, but they oscillate like this. Like maybe they're oscillating, and as they oscillate, they start getting closer and closer and closer. Like if you graph on your calculator the y equals the sine of 1 over x. The sine of 1 over x oscillates like this, and as it gets towards the middle, it actually oscillates an infinite number of times, zigzags. Your calculator kind of wigs out a little bit in the middle because it doesn't know what infinity is, and it kind of gets a little crazy. But you can see it as it leaves, it starts oscillating, but it approaches the y value. I mean the y-axis. Sorry, it approaches the x-axis, and because of that, the limit would be 0. So don't say things like, well, when it's oscillating, the limit doesn't exist. That's not true. But when it oscillates between two fixed points, like max, min, max, min, max, min, when it does that, then there is no y value that it's approaching. But that all changes if I start doing stuff like sine of 5x over 2x. Because in that case, the sine curve, if I'm going to infinity, the sine curve would be staying very small, right? But the bottom would be getting huge. And if it's growing faster on the bottom than the top, what would you say? You'd say the limit would be approaching 0, because that fraction would be shrinking in size as the bottom gets bigger, right? It's kind of like if you have a pizza and you divide it by 2 people, well, no worries, you still get a half a pizza, right? If you divide it by 100 people, now you're getting just a bite, maybe, right? And that's not satisfying, right? You're approaching next to no dinner, right? So the more you divide by, if the top's not growing at an equal rate, the top's growing more slowly, or if it's fixed, of course, it's going to shrink to nothing. What else? Any question whatsoever? Yeah.
Can you do one of the piecewise functions?
Sure. You got a page? Specifically you want to look at? Making one up might be a little tricky on short notice, but.
Page 35.
All right, so page. This one right here, 16 through 22?
Yes, sir.
Okay, so 16 through 22, actually 16 through 26, you're given this piecewise function right here. And you're asked to find the value. I'm going to be working down. All right, so 16 kind of goes to 20, kind of goes to 23. So I'm going to ask you the value of the actual function at a point, or at an x value, the value of the limit as you approach that -3, and then I'm going to ask you, is the graph continuous? Which is convenient because continuity depends on what 3 things? What are the 3 points, or the 3 things that have to occur for something to be continuous at a location? The limit has to occur, the limit has to exist of the function as you approach that value, which means from both sides, and the value has to exist, and the limit you get and the value you get have to be equal. So if this exists and that exists and you get the same actual value, then it would be continuous. Otherwise it wouldn't be. All right, so let's check this out. F of -3. To find the value, I go to where it's equal to -3. That top equation is not equal. The second equation is. So I would plug a -3 in there and I get a -2. All right, stop me at any point if I'm losing you. Okay, so -3 plus 1, that would be a -2. Now the limit, that I don't care about equal. Couldn't care in the least. So what I'm going to look at is where it's coming in from the left and the right and see if they're the same. So see if it exists. So from the left of -3, I'd have to look less than. Well, that's -2. From the right of -3, well, that's the same equation as the equal. That's also a -2. So since it approached the same value, yes, that exists also. So because the limit existed and the value existed and I got the same answer, all 3 points of continuity are checked. So this function, it may not be continuous everywhere, but it is continuous at, and I don't know why I said 3 there. I meant to say -3. Sorry about that. So, and I don't know if I changed that in my key. On my key, if I did it completely different, at 3, it is continuous because 3 would be on this horizontal line, y equals 3, right? So at the x value of 3, which is somewhere to the right of 2, it is just moving along nice and straight. So right here, I'm going to say yes, whether it's 3 or -3, but I meant to say -3. All right, and in the next column, what about f of 0? Well, it's equal to 0 there, not here, but in the second equation. So 0 plus 1 is 1. So there is a value there, right? And then the limit at 0, well, I got to check to the left of 0, which would be 1. To the right of 0 is also 1. So the limit does exist at 1. And then because the value and the limit are the same, I would say, yes, at x equals 0, this graph is continuous. Maybe not everywhere else, but here it is. And then at x equals 1, I'm sorry, at the value of the function at 1, well, there's no equal. Well, if there's no equal at all, then there's no value there, right? Maybe an open circle coming from the left and an open circle leaving towards the right, but there's nothing there. So I would say that this doesn't exist. And the second one of my 3 rules of continuity are broken, I can say, no, this is not continuous. Right? Or just no. But I got to still go back and answer the limit question. Does the limit exist? Well, as I approach 1 from the left, it's 1. As I approach 1 from the right, it's also 1. So the limit actually existed, right? The limit existed and it equals equal to 1. So what did the graph look like there? What's it look like if the limit exists but there's no value there? A what? Looks like a hole. Because if the limit exists, you know it's at least doing that, but if there's no value there, it must be approaching just nothing. A little hole there. And then lastly, what's f of 2? Well, there is an equal to, so I use this equation and got 3, or that part of the equation. Does the limit exist at 2? Well, from the left side of 2, I get 0. From the right side of 2, I get 3. So I'm approaching 0 from the left and 3 from the right. What does that look like if I approach 0 from the left and 3 from the right? What is that called? Say it louder. It's a jump, or formally, it's a jump discontinuity. Some people call those, well, no, jump discontinuity. There's no other name that I know. So that means it's jumping up to that because it's a totally separate y value that it's approaching. So the limit does not exist. And again, if any one of the points of continuity are broken, then you say that that does not exist. Sorry, it's not continuous. And then I didn't ask this question, but I probably will on the test. I'm going to ask you, like, let's just call it 26 part B. Okay, where is f continuous? So you look at the function and you go, well, there are 5 parts of this function, aren't there? What is this part? What is y equals -2 look like? What? Now that's where it exists, but what does it look like? What is the graph y equals -2? Horizontal line. Are horizontal lines continuous? So are you worried about the actual line being continuous? No, it's fine. It doesn't have holes. Lines don't have holes. Not a single, just a plain line, right? They don't have vertical asymptotes. What about the next part? What is this? What is y equals x plus 1? A sloped line? Are the sloped lines continuous? At least on their domain? I mean, maybe they don't connect in with something else nicely, but on any really line, those go forever left and right, right? No holes, no breaks. So that part's continuous. What about y equals 1? Continuous. What about y equals 2 minus x? Continuous. What about y equals 3? So all of these places are continuous. So if they're all continuous, the only thing you have to worry about is checking what? To see if the function's continuous. Checking where the breaks are, where they connect, or maybe don't connect. So let's go back. Was it continuous at the -3 break? Yes, you checked it and it was. So that means from negative infinity, all the way from far left, you don't have to stop and say, oh, I got to break it at -3. It's only continuous on that interval, because it is continuous at -3. So you can move right through -3 and move on to the 0. Was it continuous at 0? Yeah, that meant if it's continuous at 0, that meant these two functions connected. Maybe one like this, whatever, but they connected. So I can move right through 0 and onto 1. Was it continuous at 1? Oh, no, it wasn't. You checked that already. So I have to break it at 1 and then start it back up again. And you can use a union or a comma. Union's better, but AP Calculus just uses commas. So whatever. Union is saying we're joining these, we're putting these together. But AP Calculus is a little sloppy in that regard. And then I move on to 2. Was it continuous at 2? So I got to break it at 2, pick it up on the other side of 2, and then at that point I just move on to infinity, because this line just keeps going forever. So that would be where this function is continuous. Does that mean that the only place I need to check my limits are at the breakpoints? No, guys, I still have to look back at these functions. Like, what if this right here, what if this, instead of being 3, what if it was 3 over x minus 5? What if that was the function? What does that tell you? What do you know about that? There's a vertical asymptote where? At 5. If I ignore the actual functions and don't think about what they are, then I'm going to miss going, oh, wait a minute, at 5 there's a VA. VAs aren't continuous, so I would have to come down here. If that was the case, I would have to get rid of that infinity and put another break there at 5. Does that make sense? Now, what about this? What if I didn't have x minus 5? What if I had x plus 1? Say it out loud. Do I break it at -1? It looks like this graph doesn't exist at -1, and that's true. That function at -1 is undefined. But do I even use -1 on this function? At -1, I'm using what? I'm using this function. So even though that one had a break at -1, if it existed there, it doesn't even exist there, does it? So would I have to worry about that -1 in this case? No. I would just say 2 straight on over to infinity. But you have to take a look at these functions. We've talked about domain since your sophomore year, right? We've been looking at functions, and really, what are the main 2 places you worry about domain? The main 2. Where do you have domain issues? Denominators like that, or square roots. But since we've talked about that through Algebra 2, what did we find? We got to 2 other kinds of functions that have domain issues. Remember them? So, say again? Logs, because logs have to be positive. So if you ever had a log up there, like say you had something like this. Say I had log of 5 minus x. So this x value would have to be what for this to make sense? Think about it. What does this have to be right here? The stuff you're logging, this has to be what? Positive. Has to be, right? Which means x has to be what? Less than 5? So it has to be less than 5. So if I'm telling you here, from 2 to x, if x has to be less than 5, this would be a trickier question than probably you'd get asked, but maybe some other time and place. If it has to be less than 5, then where does this graph quit being continuous? At 5. See, it didn't go to infinity. Even though this says, wait a minute, yeah, it does. No, it doesn't. Graph it. You graph this, it doesn't go to infinity. It stops at 5. So that means you come in here and go, oh, stops at 5. Done. Not even equal. So I don't put a bracket on it. And then one last one, other than log graphs, there's one other kind of group of graphs that sometimes have breaks, domain issues, Particle asymptotes. Rhymes with pig. Trig, right? You got trig graphs, right? Not all of them. Sine and cosine don't, or regular sine and cosine. But tangent does, secant does, right? All those VAs in there. Again, probably not something you're going to see on this question. If I'm guessing, most of the time you see questions like this, they have maybe a denominator in there, maybe a square root. They're not making it they're making it a question about continuity, not a question about do you remember every little single morsel of what you've learned. But denominators, man, yeah, I mean, you got to be able to recognize a 3 over x minus 5 and go, wait, 5 doesn't work and 5 is in that interval. I got to omit that 5 if it was the case. Does that answer your question? Yes? What else? And if you don't have questions, I can just start randomly going through that game, and because there are some good questions in there that very often end up being test questions. Anybody have anything? All right. Let's see then. If you are just chilling, see if you would get some of these. Question number 1. Speaking of piecewise functions, could you answer this question? What's A? Say it loud and proud. 10. So the value at -2, you go to the equal sign. And -2 times 5 plus 20 is 10. That's correct. What's B? What is it? It's 10 from the left. 4 minus 3 times -2, so 4 plus 6 is 10. From the right, it's what? Negative 10. So if it's 10 from the left, and -10 from the right, then what's the limit? Doesn't exist. Is the function continuous there? No. All right? Be careful on your signs if you got careless on that. Really be careful. All right, question 2. By the way, there's probably not a lot of partial credit on this test. If I haven't said that before, because there's really, if I can do it in my head, I got to assume that you can. And I can do this in my head. What's the first thing that should jump out at you on this? And because you're going to infinity, right? If you're going towards like 3, you plug the 3 in and see what happened. But when you're going towards infinity, you're talking about growth rates. And clearly the top is growing faster, isn't it? Because it's higher power. So if the top is growing faster, what is this fraction guaranteed to go to? Either what or what? Negative or positive infinity. You know that. So at this point, it's 50-50 if you were just guessing. So how do I determine whether it's positive or negative infinity? What could I do? Yeah, so what could I do manually just to check that? She said, look at the powers and the signs. And yes, you are, but you're not just staring at them. I mean, what are you literally doing? Like, somebody tell me what they would do. Don't be shy.
X to the 4th is growing at a faster rate than x squared.
Right, and so that's how you know it's going to either infinity or negative infinity. But how do you determine which one?
Well, like, if the top one is bigger, it's going to be going to like a positive value.
Yeah, if the top is bigger, that means it's going to either positive infinity or negative infinity, but it might be going to either one. How do I check? Okay, so she's saying if I'm heading left, just pick a negative number because that's going to control the direction. So you can plug in -1 or just think, what would a negative big number in there if you raise it to the 4th become? A positive big number, and then if you multiply by +5, what would it be? So it'd be a positive value. You know that. And on the bottom, what is a negative squared? Also positive times a positive. Also positive. So you already knew that it was either infinity or negative infinity. But now, What does a plus over plus give me? A plus divided by a plus gives you a positive infinity. So that's how you know that. But it really isn't about the fact that it's bigger. Because look, this is bigger, but this would have given me a negative infinity. Why? Because a negative number cubed would have been negative, and a negative times a positive would have been a negative, and a negative over a positive would have been a negative. So you have to check the sign of that unless you just want to coin flip these. And I would guess there's at least 10 or 12 of these that are infinity. And if you're just, or negative infinity, if you're flipping coins, you're going to probably miss 6. You just lost a letter grade. Don't flip coins on those. I mean, make sure you have a plan. So this one ends up being positive infinity. But again, I'm checking. I know it's infinity because it's growing faster on the top. I got to check the signs, plus, plus. All right, what about 3? Top equation. What's happening there? So I can't plug the number in because it's infinity, right? So I got to start thinking. The bottom's doing what? It's growing faster. If the denominator grows faster than the numerator, what's it approaching? 0. You're done with that. That's 0. But what about this one? People miss this all the time because they go, oh, top's growing faster. But they're not paying attention, are they? This is like a classic AP question. AP Cal will give you a simple limit like that and switch up the powers so that the people that are sloppy, that are like, oh, bigger power on the top, must be positive infinity or whatever. But really, the powers are growing at the same rate. So if the powers ever grow at the same rate, powers are equal, what do? Take the coefficients. So take that 3 and that -7, all right? -3/7. But remember, those are only rules for infinity or negative infinity. And you don't even have to plug anything in on that one because you don't need to check which way it's going because the answer wasn't going to be infinity. The answer is going to be a single horizontal asymptote, that value. So we said 0 and -3/7. And again, not a lot of work to be doing there to look at. What about these two? What do you got on A? Plug it in and you get a 39. All right, and then so you're happy? I'm out. B. Now this is kind of clever. We haven't really done one like this, but you plug in infinity and you get what? A big positive infinity minus a what? Another positive infinity. What's infinity minus infinity? But you know, infinity minus infinity might be infinity. Might be negative infinity. Might be 0. In some strange cases, it's like really weird cases. You might have to affect it and do some algebra and it spits out crazy numbers like -4 or whatever, just because of the nature of the problem. But think about growth rates again. Which one's growing faster? That one. So this is not quite as big as that one, is it? So if I'm taking a number and subtracting a bigger number, what am I going to end up with? A negative number. And what is that number going to be if this is growing so much more fast than that? So this ends up being a negative infinity. If I switch these two numbers, it ends up being a positive infinity. Y'all see that? All right, what about this one? I'm approaching a single number, so plug it in. Hey, would you plug it in anything different if I was approaching 3 from the left side? No, you would not. When do you ever bother checking at like 2.9 and 3.1? When's the only time you would actually do that? If you know there's a VA. Do you know there's a VA yet? Well, then don't bother doing that. No matter what, if I say check from the left, check from the right, you still plug it in. The only time I ever bother even thinking about 2.9 or 3.1 is if I know there's a VA, but I don't know what's happening on either side. I don't even know there's a VA. So I plug a 3 in and I get 9. Minus 6 is 3 plus 2 is 5. And then I get 15 minus 5, which is 0. What does that tell me? There's a VA. Now, do I really need to check 2.9 and 3.1 from either side? Why not?
Because there's a unit power on top and there's a odd on the bottom.
That is true. But in terms, let me ask a better question. How about that? In terms of a vertical asymptote, why do I not have to check from either side here?
Because it's not square.
Because I know there's not a volcano-like action on that asymptote. And why do I know that? Because volcano-like actions occur when what?
It's even.
When the bottom has an even power on it, which makes it not do what from the left and the right? It makes it not change signs. Because if the bottom is squared, or by the way, it doesn't have to be just an even power. It could also be what? Absolute value, something like that. But if from the left and the right, it's not going to change signs, the top's not changing sign. It's going to be close to 5, positive 5 either way. But close to 0 could be positive, could be negative. Close to 5 is going to be positive either way. So if the bottom's not going to change signs because for some reason you had a squared or an absolute value on it, then I would go, oh, that's a volcano-like action. So that would make sure the positive stays on the bottom. The top you already know is positive, and I'd go, oh, well, if I have a volcano and the signs are both positive, it would have to do this. But this is not a volcano. So if it's not a volcano, right there, 5 over 0 is not my answer, guys. Don't leave that. But it's a sign that there's a VA, and if I know there's a VA and I know there's not a volcano, it's not going to exist here. Right? Now, what if I threw a little negative right there? Then I can't just say D and E, right? That's when I'm going to have to go, oh, well, let me check from the left side of 3. So what would you plug in? Now, hypothetically, if I plugged in a 2.9, do I really have to do the math on that? Do I have to plug 2.9 and square it minus 2 times 2.9 plus 2? Because what am I going to get if I plug in like 2.99999? Pretty much 5. What am I going to get if I plug a 2.9 in there? Now, be careful. A 3 gave me 0. A 2.9 is going to give me what? A little bit smaller than 15 here, right? Which would make a little smaller than 15 minus 15, which would make that negative. So you don't have to actually do the math on that. Just think about it. But doesn't that tell me now that, wait, if the bottom's slightly negative and the top's still positive, that would mean that at this VA, what's happening from the left? We're going down. So in this case, if it was from the left, I would say negative infinity. So really, in those cases are really the only times you have to go in there and plug in and check, is when you really need to know from one side. Yeah, by the way, that was before I put the negative on it. What about this one? Not much different, right? Still get 5 over 0. What's different about this stuff?
Squared.
And the squared guarantees that no matter what I plug in from either side, what's the bottom going to be? And what's the top going to be? Still pretty close to 5. So you already know there's a VA. So that means from either side, it's going to be going positive over positive, which means going up. So infinity. So did the limit exist here? No, because what does infinity mean? It doesn't exist, but rather than just stopping there and going, hey, the limit doesn't exist, and you're like, it doesn't exist. What does that mean? There's no limit there. Now I go, it's infinity, and you go, oh, that means it doesn't exist, but it's going up to infinity on both sides. So it gives you a little more information. But the limit doesn't exist, even if you write that, because that means DNE and going up forever, or mathematically unbounded in the positive direction. All right, what about this? Oh, there's your infinity. Okay. Kind of already addressed this. 5 from the left. Are you going to plug 4.9 in? No. You don't even know there's an asymptote yet there, or there yet. So plug in a 5. 25 minus 25 minus 7 is negative 7. Plug in a 5, 0. Oh, there's a what? There's a VA. So how do I check 5 from the left? Plug in a 4.9. Do I physically have to plug in 4.9 in the numerator? Because what's 4.9 or 4.99 or 4.99999 going to give me? About negative 7. Now what's 4.9 going to give me here? Small, close to 0, but negative. And what does negative over negative give me? Positive. So that means from the left side of 5 coming in here, it's shooting up. If it's shooting at, gotta go with that. Y'all tracking with me? All right. What about this guy? Same thing, right? Except this time, 7 in there gives me -4. 7 in there gives me 0. I know there's a VA, but what does the absolute value tell me? Regardless of what side I come in, it's doing what? Staying positive. Has to be a positive value, which means the left sides, the left and the right side are always positive. So right there, I know from both sides I'm going to end up with a what? Negative or positive is negative. It's got to be shooting down because there's a right? How about this? This question showed up on an AP test we did yesterday in class. We did a practice problem, and it said, find the values of, there might have been an A and a B instead of a K, but find the values of blah that make that continuous. How do you check to see something's continuous? The limit would exist, right? So how do I check the limit? I check from the left and the right. Where's the left and the right here? Not equal means left and right. Again, that's terrible in math, but it's like if you say, and I've used this example 100 times, if you say, I hate broccoli, that doesn't mean you love everything else. But in math, if on a piecewise function, if it's not 4, that means that it's everything but 4. Right? So this is greater than or less than. So when I plug 4 in there, I get 16 minus 8 is 8. So the limit is 8. Okay? Now what is the value? I plug a 4 in there, and I get 5k minus 2. So from the left side and the right side, I got 8, right? The left and the right equaled 8. And then at the value, I got this. But doesn't the left and the right and the value all have to be the same? So you don't need to be redundant there. So you go, oh, well, if that's true, then I can add a 2 and divide by 5 and get my k value that would make that true. So I'm kind of forcing k to have some value. And then if you plug the k back in there, you'll see that this is true. And it's continuous there at that point. Right? All right, how about this? I tell you, every year I get people that do a fantastic job on trig limits, and every year I get people that they kind of wing it. They've been maybe not doing their homework. They get to the test and they're like, yeah, I skimmed over that. It seems like I just grabbed A and B a lot. And they go in there and they grab A over B, and they do it all day long. But what's the thing we always do with limits to a value? Plug it in and see what it's telling you about the problem, right? So if I plug a 0 in, 3 times 0 is 0. Tangent of a 0 is 0. 0 times 4 is 0. And 0 times 5 is 0. So what does that tell me? There's a hole. Unfortunately, we don't know how to factor tangent. So what do? We go to those rules. And what are the 3 conditions I said to look for? If it is a trig function of a number times x, or there's a number times x. You can put those in any possible combinations. Trig function number x over trig function number x, trig function number x over number x, whatever, flip them. If it's that, not squared, not any other junk going on, but if it's that, you can always take the coefficients. But what do you do about this 4 sitting on the outside? You ignore that part for now. So really, it's like 2 limits. It's like the limit of 4, which is 4, and then it's like the limit of that, which even though that gives me 0 over 0, you go back and take what? 3/5. And that ends up giving you 12/5. But the problem is people get down here and they do the same thing. They go, oh yeah, it's another one of those A over B's. 4 times 3/5. But you don't get 4 times 3/5. What do you get here? If you plug a 0 in, you get 3 times 0 is 0. Cosine of 0 is 1. 1 times 4 is 4, right? And then 0 times 5 is 0. What does that mean? There's a VA. Is there anything squared on that bottom that's going to make it go in different direction? The same direction? No. So if it's got to go in different directions, what's the limit? It's got to be DNE, doesn't it? Move on. But you've got to plug it in and let it tell you what to do with this. Right? And don't forget that 4 on the A. All right. What about this? If you get 0 over 0, what does the graph typically have at that A value? Oh, why did I say typically? Because we did that one yesterday where we got 0 over 0. And then when we went to finish it up, we canceled out the common factor and we redid it. And when we redid it, we didn't get an answer. We got a number over 0. And that number over 0 then tells me there's not a hole there. There's actually a what? A VA. And that VA kind of trumps the hole. All right? So in this case, that typically means that there is a hole there. And do limits exist at holes? Oh, yeah. A hole is an open thing that goes in one side and out the other. Yeah, they totally exist there. All right, what about this? Oh, that's the answer. 3 rules of continuity. I want you to tell me what to write here. Let me show you how you're going to how a lot of people mess this up. Literally, somebody volunteer. Okay, she's going to take one for the team. She might be right, she might be wrong, but if she's wrong, I'm almost happier because you'll see. Okay, so tell me what to write here without looking at it in your work. So f of c. Notice she didn't say f of x. Because of course the function exists. I want to know if the function exists at C. And sometimes I use A, right? So f, the function, at that C value exists. Great.
And then the limit of x approaching C, f of x exists.
Good. You know what a lot of people write? They go, the limit exists. But she didn't say that. She said the limit as x approaches C of the function. And the function, do I write f of C? No, here I write f of x. So that, the limit of the function as x goes to C exists. And then lastly, what? Nah, let's not get lazy. Come on.
Come on.
We're only talking a few seconds. The f of C equals the limit of f of x as x approaches C. But be careful about little details like that, because that's a test question right there. I guarantee you that's a test question. And almost, I'd say 9 times out of 10, it's a 3-point question on your AP test in calculus. They'll either have you just state it, or they'll have you acknowledge it in some way, or have to check it, and it happens at least for 3 points. All right? And the order doesn't really matter, although I usually put that one last. C last, but whatever. All right, what about A? A lot of people are going to write 3/4 on this. A lot of people are going to miss it. Well, hopefully not. What are our rules for doing limits? Plug it in. I plug it in, I get 0 times that is 0, sine of 0 is 0, 0 squared, 0, 0 times 4 is 0. What does this tell me? There's a hole. Now, does this meet one of the 3 conditions I told you to find? Trig function of something x over something x. No, it's trig function of something x over something x squared. So what I have to do is go, well, if it's 4x squared, I've got to separate one of those x's and just pull it out here and make a new function out of it. Now, you could just have, I guess you just put 1 on the top. And then I treat these limits separately. Now, what is the limit of that? Well, when I plug it in, I still get 0 over 0, but now it meets one of my conditions, doesn't it? So since it meets the condition, I go, oh, 3/4. But only because I got 0 over 0. Remember, you've got to do that. But then what happens when I plug a 0 there? I get D and E. What do I do with that? What's something that doesn't exist times 3/4? Something that doesn't exist? What about this thing? So, what about that thing? I plug it in and I get 1 on the top and 0 on the bottom, which means there's a VA. So if it's that 0 over 0, I don't use any of those trig rules. I go back to what I know. What do I do with VAs? Do I just say D and E? It is not going to, it doesn't exist. You're right. But can I say more? Since I get 1 on the top and 0 on the bottom, I know there's a VA, but what do you see down here?
Volcano.
It has to be a volcano because is there any way for that denominator to be negative? No, you're squaring anything that goes in there. Whether you plug in 0.1, negative 0.1, you're getting a positive number there. The top's already positive. Okay, it must be doing this. Y'all seeing these? Don't just memorize that A over B junk. That kills you. What about this? It's only 14. I'll probably post this key up after school. I'll try to remember to do that, but what do you do with these? I see infinity. What do I need to start thinking? Growth rates. Oh, crud, though, but growth rate of 4x squared something? What's 4x squared something if you start simplifying it? Absolute value of 2x something. So I can replace this with absolute value of 2x something. Well, that's still a little annoying because how does absolute value look? I know those are v functions, at least when they're linear. But which way am I going? I'm going to the right. So which arm of the absolute value do you use? Do you use the 4x or do you use the negative 4x? If you're going to the, if you're going to the left, you use the negative 4x, right? So since I'm going left here, I go, well, I can't use that. I'm just going to use the regular negative 2x something. And then now I go, oh, now I've got it simplified down to the same growth rate. So what do I do with that same growth rate? Use the coefficients, negative 3 half. And here, what's a cube root of 8x cubed, blah, 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 blah. 2x something? Do I have an absolute value on that? No. I'm good to go then. That doesn't, if it's not absolute value, it doesn't change signs. Do I have the same growth rate? X and x the first, x the first. So 3 halves. Y'all seeing these? Are you fearful or are you like, all right, I'm kind of getting my legs under me? Or I'm still in a coma? Huh? These get people every day. Here's, I got 2 minutes. Check this out. Every year I have somebody go, oh, coefficients, constants I can ignore. And then they go, all right, that's 3/4. A over B is 4/3. Must be equal to 1. What did you not do? Plug it in. What happens if I plug it in? What do I get? I get cosine of 0 is 1. 1 times 3 is 3. Cosine of 0 is 1. 1 times 4 is 4. I'm done. But here, what do I get? 0 times 3 is 0. 0 times 4 is 0. So here, I break it up into 2. And I go, what does this part give me? That gives me 4/3. And what does this part give me? That gives me 3/4. So it must be 1. I got 1 minute. Y'all seen this function? Super, super common AP function.
That's nice. Nice.
If I plug a 3 and I get 0, check the key. Or come see me after school. Y'all have a good one.